right, ladies and gentlemen, let's take a look at the second part of lesson 2.1. And now we're actually going to be constructing lines. We're going to be constructing linear equations. We know these are linear because x is raised to the first power. That's our linear function. So here we see y equals x minus 2. What we're going to do today is we're going to construct a table of values. And so we're going to have 5 values. I think I need to extend my table a little bit here to match yours. But we're going to have a table of values, and then we're going to plot the points and draw the line through there. And so what we usually like to do is we like to see something on the positive side of 0 and the negative side. So we'll have 0, and I think for the graphs that you have, we'll need to use positive 1 and positive 2, and negative 1 and negative 2. Now you have a couple of options. You can do this by plugging those in for x. So you'd have y equals negative 2 minus 2, which is negative 4. And so you can go through and do that math by hand. Now the other option you have then is to use the technology that we have. And I have over here the keystrokes that we have. So as I'm going through here, if you can't quite see on the video what it is. But you need to go to y equals. We're going to input that function. And right now there's some functions in there, so let's hit clear. And we're going to type in what it was. It was x minus 2. So x is the second row, second key n. And then we had minus 2. Then what I want to do is I want to go look at my table, but I'm going to start with table set. So it's second and then the window key. It says the table set there. If you look here, you can see table set there. All right. But what we have here now is, where is our table going to start? Well, we're going from negative 2 to positive 1 to 0. Or I'm sorry, negative 2 to negative 1, then 0, 1, and 2. And so we're counting by ones. And we want it to automatically fill those, so those things look good. So we're going to go second and then graph, which brings up the table. And we can see those values. So there's that y value of negative 4 that we calculated. So we're going to type right into our table negative 3, negative 2, negative 1, and 0. We should see a pattern with each of these that we do, because that's one of the characteristics of a linear function. So we're going to negative 3, negative 2, negative 1, and 0. We're going to plot those points. So negative 2 on the x-axis, negative 4 on the y. We did some graphing yesterday. Negative 1, negative 3. 0, negative 2, 1, negative 1, and then 2, 0. We're not creating a line segment, we're creating a line, so it's going to go past those 5 points. We're going to put arrows at the end to show that this continues. That's what a linear function does. So there's your first linear function. All right, so now we're going to take a look at this next one. We want to construct a table of values, plot the points. I'm not going to start by typing in or picking my x values. What I do want is I want x in the middle. But the way I'm going to start this one is I'm going to type in the function negative 1/3 x plus 4. So we'll go to y equals. Actually, let me clear the keystroke history. We'll go to y equals, and we'll clear out the function that's there, and then we'll type in negative 1/3 x, and then I forgot what the function is, plus 4. So negative 1/3 x plus 4. And then we're going to look at our table. And what I want to do is I want to be able to plot nice points. So right now, negative 2 and negative 1 don't look very nice. They're giving me decimals. But if I go up one space, negative 3 gives me a very nice value. So I've got negative 3, 5, that is a nice value. I've got 0, 4, that's a nice value. And 3, 3, that is a nice value. The problem is I want to have 5 of them. So that means I'm going to have to cursor up in my table. So I'm going to hit arrow up again. Another decimal at negative 4. Another decimal at negative 5. But at negative 6, these multiples of 3, we're finding nice values. So negative 6, 6 is one of my values. So we're going to have negative 6, 6. Double check to make sure that's what we had there. Yep, negative 6, 6. Negative 3, 5. 0, 4. And then if we go back and look on the positive side, we'll cursor down. We'll cursor down. 3, 3, and then I'm going to guess we'll find another one at 6, and we have 6, 2. So we're going to do 3, 3, and 6, 2. Now the reason we ended up with these multiples of 3 is because our denominator was 3. So the denominator helps us determine good values if we don't have a calculator to help us with that. But we'll graph negative 6, 6. We'll graph negative 3, 5. We'll graph 0, 4, 3, 3, and 6, 2. Connect those the best you can freehand or get a straight edge. Use the edge of a piece of paper. And there we go. We got a couple more to look at real quickly. We have y is equal to 3. And we talked about this a little bit when we were doing function notation. There's nowhere to plug an x in. So if I put 0 in the middle, and I put 1, 2, and then negative 1, negative 2, there's nowhere to plug those x values. So that means my y value is always going to be 3. Now you can test that by going back to your calculator. We go to y equals, we hit clear, and then type in y equals 3. There's no x to go with that. And sure enough, if we look at our table, that's all we have, are a bunch of 3s. And so it should fit with what we did at the beginning of this lesson the day before, that our output is always that y value when there's no place to input x. So we're going to plot negative 2, 3, negative 1, 3, 0, 3, 1, 3, and then 2, 3. So we get this horizontal line through the y-axis, which is pretty important for us to recognize that we're going through the y-axis, because on our next problem, we have x equals negative 2. I can't go start putting in 0, 1, 2 because it says x has to be negative 2. So that means all of my x values this time are predetermined for me. But my y values, I can pick anything I want. I want it to fit on my graph, and I want to get a good representation of what this line is doing. Hopefully you're starting to see some sort of a prediction that we should have. If y equals went through the y-axis, hopefully x equals is going to the x-axis. So I'm going to do negative 2, negative 2, negative 2, negative 1, negative 2, 0, negative 2, 1, and negative 2, 2. And sure enough, this x equals line goes through the x-axis. You have 2 problems on the back side on your own. You guys need to do those, and we will check those together tomorrow in class to make sure you don't have any misunderstandings. We'll see you then.